All right, welcome to The Explainer. Today we're diving into a really big shift that's happening in artificial intelligence. It's a revolution that's not just about what AI can do, but where it does it, moving from these faraway data centers right onto your very own computer.
For the past few years, we've all gotten pretty used to chatbots, right? They answer our questions. But what if an AI could take your request, figure out a whole multi-step plan, and then actually go and do it, all on its own? That's the huge leap we're talking about today. So this new way of doing things is called Agentic AI, and these are not your passive chatbots. No, these are active problem solvers. They can perceive what you need, they think, they make a plan, and they use different tools to get the job done, all without you having to hold their hand through every single little step.
So how do they work?
Well, it's all about this simple but really powerful loop. First, they sense the goal. Like if you said, summarize the latest news for me. Then they plan out the steps. Okay, I need to search the web, read a few articles, and then write a summary. And finally, they act. They go and execute that plan. This sense, plan, act cycle is the engine driving them, and it just keeps on repeating until the job is done. Okay, so let's get into it. What really makes this so different from the AI we've been using up until now? You know, the difference is actually huge. A traditional LLM is kind of like a vending machine. You put a prompt in, you get an output. One and done. But an agent, that's a continuous process. It has this kind of internal monologue, a chain of thought, where it's constantly reasoning and reevaluating its own plan. And that iterative loop, that's where all the power comes from.
But all of that thinking, it comes with a price tag, a very, very big one. And that brings us right to the central problem of trying to run these powerful agents in the cloud.
See, the problem isn't the final answer you get. It's that internal monologue we just talked about. Every single step in that sense, plan, act cycle is another call to a cloud AI model. So you're not just paying for the result, you are paying for the thinking. And every single thought costs money.
In fact, get this. Research shows that an agent's internal planning can churn through over 10 times more data or tokens than what you actually see in the final answer. All that hidden work adds up, and it creates this massive multiplier effect on your final bill. So, take a look at these standard cloud rates. This is per million tokens. Now, apply that 10x thinking tax we just mentioned. Even the cheapest models start to look pretty pricey, and the really high-end ones? At $75 per million output tokens, a complex agent task becomes, well, financially terrifying is a good way to put it.
And it doesn't stop with the tokens. For an agent to be useful, it needs tools, like searching the web or running code. Well, guess what? The cloud providers charge extra for those too, adding another layer of cost. Your agent's simple web search could tack on another $25 for every 1,000 times it does it. It just keeps adding up.
So, if the cloud is basically a financial minefield for agents, what's the alternative? Well, the solution is to bring the AI home and run it on your own hardware.
Going local completely flips the script on the economics. Cloud APIs are a recurring expense that just grows and grows with every thought the agent has. Local hosting, on the other hand, is a one-time capital expense for the hardware. After that, the cost to run your AI, to let it think as much as it wants, is essentially zero.
And the benefits go way beyond just saving money. You get absolute privacy because your data never leaves your machine. You get total control to fine-tune the models for your specific tasks. And you get speed. We're talking near instant responses with no network lag. It even works when you're completely offline.
Okay, this all sounds great, but how is this actually possible for a regular user or a developer? Let's take a look at the tools that are making this whole local revolution happen.
Say hello to LM Studio. Think of it as your command center for local AI right on your desktop. It's a free app that lets you discover and download all the great open source models, test them out in a chat interface, and, this is the most important part, it lets you launch a local server with just a single click.
Now, if you're a developer, this line of code for connecting to OpenAI's Cloud API
probably looks very, very familiar. It's been the standard way of doing things for years. Well, with LM Studio, you use the exact same code. The only thing you change is you redirect the address to your local machine instead of the cloud. This simple little switch is an absolute game changer. It unlocks the entire ecosystem of AI tools that were built for the cloud and makes them work locally for free. So, how do you actually fit a massive AI model onto a regular laptop? The first piece of the puzzle is a technique called quantization. It's basically a compression method that shrinks the model's file size by slightly reducing its numerical precision. The best analogy is probably saving a photo. You can have a huge, high-quality image file, or you can have a compressed JPEG that's way smaller but looks almost identical to the naked eye. Quantization is doing the exact same thing, but for AI models. And what's cool is this gives you choices. You can go for maximum compression to get a tiny file with very good quality, or you can use less compression if you've got more memory and want a model that's practically lossless. That trade-off between size and quality, it's completely up to you.
The second piece of magic here is something called knowledge distillation. This is how these small open-source models get so incredibly smart. A smaller student model is trained to mimic the thought process of a massive teacher model like GPT-4. It learns not just the right answers, but the teacher's style and reasoning, packing all that capability into a much smaller package.
So, does all of this mean the cloud is obsolete? Not at all. The future isn't a battle. It's a partnership.
The smartest strategy isn't cloud versus local, it's cloud and local. You use your fast, private, free local models for the everyday thinking, the routine tasks, and then you only escalate the absolute most complex problems to those expensive cloud models. You really get the best of both worlds, power and economy.
And that leaves us with one final big thought. This isn't just about cost or privacy. This is a fundamental shift in our relationship with AI. When these agents run on our personal devices, woven into the fabric of our digital lives, what new possibilities will we unlock? That is the local revolution.